Welcome to RITSEC. Yippee! Join the Discord. Join the Discord so you can sign in. Chase is dropping the sign in right now. And then you guys can sign in. This is how you get pizza, and this is also how we know how many people are active in our club. Check the calendar. We have fun events going on. We always have our interest groups, slide roulette, everything like that, all in the calendar. Go check that out. The RITSEC mailing list. Raina works really hard on our newsletter every week. And the IG leads and e-board work very hard on putting important things in there. So please join our mailing list. Feedback. Not only can you go to feedback.ritsec.club, you can also use the /feedback command and notify all the e-board about what your feedback is. And I think it's anonymous. Don't abuse it, please. Yeah, the feedback. Education topics. If you have really cool education topics, submit it here, and then I'll look for it, and then I'll hopefully be able to incorporate it, or the next head of education will be able to incorporate it into our education topics for the next year. Announcements. We have our CTFCA election next week. We have 2 nominees, Ariana Cestini and Rachel Leone. Yay! Elections will begin next meeting, at the start of next meeting, so everyone please be here. They'll have some time to present and then some time for questions, and then they'll leave the room and then we'll discuss it for the 2 of them, which is great. And then after that, we'll have slide roulette. Cool. IRSEC photos have been released. I believe there should be an announcement in the Discord about that. If not, it's coming shortly. So you guys can go see everybody who signed the photo release forms. They are in the pictures. Everybody who did not, you are not in the pictures. Yay. Or everybody who requested not to be in the pictures. Call for mentors. We'll be having mentorship programs run again in the spring semester. Please contact Chase if you would like to be a mentor. The form closes. When does the form close, Chase?
Whenever I get around to it.
The form closes whenever Chase wants it to close. And then we have slide roulette. Please submit slides and do slide roulette. It's very silly, very goofy. We'll have a good time, and they're due December 6th at 5 p.m. Cool. And the sponsors. Lastly, follow our social media. Ariana does a great job. Her posts are really cool. She posted about this meeting. So if you ever have questions about the education topic or the research presenters, you can look at our Instagram and the mailing list. But Ariana posts all the information on the Instagram, and it's cool. Yay! And then we have the Docker Talk by Michael Scalzetti, our ops lead. Yay! Clap it up.
All right, cool. We're going to pretend like this isn't the camera app. We're going to pretend like this is just my screen. And my screen alone. Okay. Welcome to the Docker Talk. You can set it in here. All right, we're having a bit of an Arch Linux moment. I can't actually share my screen because driver stuff. And yeah, so we're just going to roll with this. Self-service. Okay, that's good. Okay. ASMR. All right, so who am I? I'm Michael, also known as Scals. Interests, I do home labbing stuff. Recently got into motorcycles. Those are my 2 little bikes in the corner. They're very cool. Thank you. I also take pictures sometimes. It's kind of one of those things that I get into and out of. Not big on cameras, but pictures themselves are cool. So don't ask me about camera models. I know nothing. Here's some pictures and stuff. Took pictures of the moon one time. That was cool. Yeah, these ones are on film, so that's cool. All right, you guys should learn Docker, so we're going to do that, okay? What is Docker? That's a good question. We can't answer that yet because we need to ask, what's a container? But in order to answer that, we need to know what's virtualization. So, you know, in computing, virtualization is the act of creating a virtual. That's boring, okay? So TLDR, you have a computer on your computer. You virtualize, you make fake versions of storage, network, hardware, whatever you need in order to get that software to work as its own little isolated sandboxed thing. So a virtual machine, continuing off of that, is something that uses virtualization. It makes a emulated version of all of your computer's hardware, including CPU, RAM, things like your TPM module. Stuff like that is all virtualized, so you can put software like a BIOS, an operating system, and any like software like Zoom or Chrome or viruses, etc. That kind of software on it, and have it completely separate from your host operating system. It looks something like this. So you have your real hardware, then you have some sort of hypervisor, in this case a VMM, and then you have like simulated hardware, or the simulated machine, then your OS, and then your applications. So there's a lot of overhead because you have to be computing. Your CPU has to take time to pretend to be another CPU before it can actually process anything. So containers come in and they get rid of a lot of that overhead. They can reuse your hardware, and they basically act kind of like troops. They sandbox, but not by virtualizing hardware. So it's basically an OS or program only on top of your existing operating system. What Docker is then is a way to orchestrate those containers. It makes using, managing, destroying, doing anything with containers way easier. There's other technologies like LXC and stuff like that which compete with Docker, and Podman. Devin's not here. Like Podman, for example. Yeah, they're all very cool. But Docker is my one and only. It looks like something like this. So again, on this side you can see more of a VM, but on the left you can see that's what Docker looks like. The hypervisor and the guest operating system isn't there, so there's it's a lot more direct to the hardware. So you get better performance, and there's a couple other advantages on top of that, which we'll get to in a moment. The basic overview of how it works is that within Docker, you have images. Those images can be anything. It can be full-on Debian OS. It can just be Python. It can be a web server like Nginx or Apache. And those act as templates. When you want to spin up a Docker container, you take one of those images or these templates, and you specify how you want to run the container, and it'll just spin it up. So then once you have that running container, you have this OS running or whatever within this container. You can add it to different networks. You can use volumes to save the information on that container, either on your disk or as like a partition section within Docker itself. And there's a bunch of different stuff. On the right, you'll notice that there's a little bit of a diagram here. The client and the server for Docker are technically two different things. We'll talk about this a bit more in a second. Actually, yeah, we'll talk about that in a second. It's actually really interesting. Yeah, that's a lot of funny stuff. So let's take a step back and just look at some examples, right? So basic Docker commands. If you want to pull an image or download an image off of a registry like Docker Hub, which if you want to check out what images are available, you can go to hub.docker.com and just scroll through. There are like literally millions of different images. But you just do Docker pull, and that downloads the image, and that's it. You're done. If you want to build an image like custom, you can make what's called a Docker file. There's great documentation online for it, and I actually have a cheat sheet on my blog, which is blog.scalz.cloud, which you can use as a cheat sheet. It's great. And you can build your own custom image. So if you want to like make a Minecraft server or something like that, and you're like, damn, all these images on Docker Hub suck, make your own. Very easy. It's basically just like glorified bash scripting. In order to run that image, once it's ready, you just do Docker run and then the image name. There are some like options you can use, like Docker run -it will run the container interactively, or I is for interactive and T is for TTY. So if you're running a Debian image and you want to be able to get a console so you can type stuff, do Docker run -it Debian, and that's it. It's very easy. That's all you need to do to get started. If you want to use it for a server, then I would highly recommend looking into Docker Compose. You make a file that tells Docker all of the run commands that you want to do, and it'll just do them automatically. If you want to update all the images that you're running, you just do docker compose pull, and then docker compose up, and all the images that are running will just update, and then you're done. It's 2 commands. It's great. So yeah, why even bother using Docker, right? Like, what are the advantages? Why would you want to get involved with this? Usually it's a lot quicker to get a service up. Let's say you want to run like a web server, or let's use the example of Nextcloud. Okay, Nextcloud is a big application, or even WordPress. Big applications that involve like a long process to install. Or you can go on Docker Hub and someone already made an image and went through all the effort of doing that. And so now all you have to do is edit the config file to be close to what you need, and then mount a couple volumes so that you can save changes that you make to the website. So you can like save like your files for Nextcloud, like your user files, stuff like that. So compare that to installing the entire thing from scratch. A lot of services nowadays don't even will prefer that you install stuff with Docker and won't give good docs on how to install it on the metal, because it's just so much easier to do it on Docker, and they don't have to worry about you making issues while installing the software because it's already installed properly. It's an image. So it's a lot quicker. It tends to be simpler because of that. It performs well with any tinkering, without any tinkering, sorry. So if you're using virtual machines, maybe you've experienced that you have to go through and you have to mess with how much CPU and RAM to give the machine. You want to adjust how much storage you give the machine. You want to adjust, like, this is the exact CPU settings that you're going to use just so you can run a bit faster. With Docker, you don't have to do any of that. It just works, which is excellent. You can use Docker to improve the native support of your system. I remember I used to run an OS that probably a lot of you guys have never heard of before, called Void Linux. Void is amazing. If you have a chance to mess with it, it's great. It's basically, it's kind of similar to Arch, but if Arch did not have systemd and was even more stripped down. It has nothing on it, which sounds terrible, but it's actually amazing. The entire OS is just a bunch of bash scripts, and you can like literally just take it apart and see how it works. But the issue with that is that not a lot of people support Void. So if you want to use certain applications, sometimes you can't find them. You can emulate them with Docker, and as long as they're a command line tool, it's like it's running on your system, and there's no issue at all, which was great. I had a lot of experience with that. It was a good one. You can also make stuff into services very easily. You set up an image and you run a command, and you can just put that in the background. And if you tell it to restart always is the key. If you tell it to always restart, then even when you restart your machine, that container will spin back up and start running that process again. So it basically, you don't have to worry about like making a service file or setting something up with systemd, because you can just do it through Docker, which is not really an intended use case, but it's one that is very useful sometimes. It's also really easy to clean up. You want to delete everything in Docker, you do docker system prune-a, and everything is gone. It's like super easy to clean up. So I didn't, this is not a misquote. President Munson definitely said Docker is kind of based. I'm just saying, So yeah, let's do some examples real quick. So I mentioned websites. Well, in order to access a website, you need to be able to connect to a port. By default, Docker will do this thing called matting, where it'll translate the address of the container to be a private one. And the benefit of that is that you can run containers without worrying about people connecting to them. But that means that when you're trying to get people to connect, you have to manually make something available. So I think we can just go over here, and I will blow this up a little bit. Okay. So in order to run an image, remember earlier I said that you could just do docker run it debian, and the -- rm, don't worry about that. That just means after the container is done running, delete it. That isn't important. That doesn't affect how the container runs. It affects how it stops. -it, if you remember, is interactive in TTY. So I want to be able to send commands into the container, and I want it to give me a TTY shell. I want to be able to actually treat this like a shell. If I run this command, it'll boom, drop me into a container. You'll notice that the host name is different. So now we're inside of a container. You can see if I go to the root directory, there's nothing here anymore. If I'm in the root directory for this machine, there is stuff here. So you can see it's different. It's a different machine. If you want to forward ports, You can do Docker run. Actually, yeah, that's fine. Do the same thing. I don't need this to be interactive this time. What I need to do is I need to forward ports. So I'm going to forward to port 8080 on my local machine from port 80 in the container. And I'm going to run HTTPD. And I'm also going to do this with -D, which will run this in the background. It's detached mode. So if I run this, you'll see it'll download the image automatically. Give it a minute. And then it'll start running the image. And we can do docker ps to see if it's running. And we can see HTTPD is running in the foreground on port 80. If we want to check if we can hit that website, boom, it works. Super cool. And if I wanted to install that manually, I would have had to have gone to the Apache docs and install it manually, go through and make sure I had the config right. Or literally one command that I did just off the top of my head, and it works. It's very, very, very easy. Volumes. If I want to make their examples. If I want to make a file available within a container and not within that container, actually I'm going to stop that. Also, to stop a container, you just do this, docker stop, and then the name of the container, which is hopeful Heisenberg in this case. Super easy. That's gone now. If I want to make a file and make it available inside of a container, I can touch a file. This file is empty, so let's echo hi into the file. Sorry. So this file says hi, right? So let's make a Debian container. So again, --rm, delete it after I'm done. IT, make it interactive so we can get a shell. This time we're going to use -v. Okay, we're going to mount a volume. I want to mount ./file. That file I'm going to mount to /file within the container, and I'm going to start another Debian machine. If I ls/file, it's there, and I can also cat it, and it works. I can see that file, and I can interact with it. I can also actually Vim isn't going to work, but I can do echo hi there into the file. Now if I cat the file, both of those are there. If I quit the VM or quit the container, sorry, it's not a VM, and I cat the file, you can see that that change was made on the host machine as well. So they're mapped together. As far as Docker is concerned, it's the same file. Another thing you can do with this is you can actually make files read-only as well by adding this :ro. So you're saying map ./file on the local machine to the /file file on the container and make it read-only. Now, if we want the cat /file, it'll work. But if I try and echo stuff like nope into /file, read-only file system doesn't work. So if you want to protect your configuration files, for example, this is a great way to do it. Docker supports it natively. Very cool. Very nice. Next thing is entry point. You can actually control what a container runs when it starts up. Do you guys remember when I did that HTTP container a little bit ago and I forwarded a port? The way that works is that container, when it starts up, runs a specific command. You can actually override that command and get a shell, for example, into a container. So what we're going to do is instead of forwarding this port and instead of running it in the background, we're going to run it interactively. And after the image, so it says HTTPD, that's the image that we're referring to, we're going to run /bin/bash. And now, instead of running the Apache service on startup, this container is running bin bash. So I get a shell on this machine instead of it trying to run the Apache web server service. This can be really useful for debugging. Let's say you have an Nextcloud container that you're trying to get working, and for some reason it's giving you file permission errors. Do override the entry point, run a shell, look at the file permissions with your shell, ls-la, see what's what, and maybe you can root out the issue. Makes it a lot easier to debug. Alternatively, you can still run that container in the background and get a shell after the fact using docker exec. So this is running in the background again, docker exec, which basically works like docker run, but executes something after a container is already started. So docker execute interactively, if you remember that command again, into the image that or the container we just started. Whoops, that's not the name. Invaluable Wilson. Right, I need a command. Bin dash. There we go. So that also works. Now this container is running the web server, and actually, does that have curl? Does not. No. Okay. So this machine is running the web server, and I also have a shell in it at the same time now because I was able to use Docker run to start the container, and then I was able to use Docker exec to execute a command after it started. Does that make sense? All right, cool. And again, you can see if I curl localhost 80, if I can find that command, so I don't want to type it again, so lazy. That still works. So again, those two commands were running at the same time. We can stop that now. And Wilson. Typing's hard. All right, and the last thing I wanted to give a demo for is a compose file. So we can actually show, this is how the demos are working actually, is using a Docker compose file. So if I cat this, you can see that there's some information about how I want this Docker setup to work. And it's pretty readable, I would say. It uses a format called YAML. It has a base version for what Docker Compose version you're using. You can kind of just always say 3. I've never had a situation where 3 doesn't work. I don't know the difference between the versions, to be honest, but I've never had an issue with running 3. Under that, you say services, the different services of the different containers you want to spin up. So one of the services in here is the registry. That's what it's called. You can see services registry, and then you can name that container. So I named it registry. So if I do docker ps-a, you'll see that there's a container called registry. Again, going back, I forward ports. I specify what image. So on Docker Hub, there's an image called registry. That's what we're referring to. That is a Docker registry. I don't know. It basically just is a place for you to upload images to, Docker images. I mean. So you can pull and push templates to this. Runs on port 5000. The network that it's on is called registry net. You'll notice that the other container on here called Caddy is also on that network. What that means is since these two containers are on the same network, they can actually resolve DNS across each other by host name. So the registry has the name registry. The Caddy image has the name Caddy. So I can say from Caddy, ping registry, and it'll automatically resolve that IP to the correct local Docker IP address, which is a private IP address, which is really useful for this because Caddy is a reverse proxy. So I can use it to redirect traffic, HTTP traffic, directly to the other image without having to specify an IP address. I just say this is the name of that container, and it'll automatically redirect it to the right place. Very useful. So that's what Caddy files or Docker Compose file looks like. There's you can set up Docker Compose to do any number of things. In my home lab, I use it to spin up Nextcloud, for example. I have my own Git server, which is basically a Git server, like GitHub or GitLab. Those are all ran by Docker Compose. And if you want to update the images being used within your Docker Compose, again, you can just do Docker Compose pull. It'll check to make sure that those images are the most up to date. In this case, they weren't. And so now it's pulled those updates. And what I can do is I can do Docker Compose up-d, and it'll recreate those images with the most up-to-date version of that image. And now these images that were out of date before are now fully up to date. That's it. Just 2 commands, fully updated. Docker Compose is great. Love Docker Compose. Yeah, there are some things that make Docker a bit complicated. It is what it is. Networks can be a little wonky. They're one of those things that you should read the docs for if you're going to use them a lot. By default, Docker will put all new containers, unless specified otherwise, on what's called the bridge network. What is the bridge network? It acts similarly to how a router works. You have an IP address for your machine. Let's say it's a let's say you're on the RIT network. It's a 129.21.something.something. Docker doesn't want to reuse that IP address because it might try and open a container to listen on port 80, and you might have something listening on your local machine that's also listening on port 80. That causes a conflict, that will break stuff. So let's give these containers a new IP address. But they also still need to be able to access the internet, to be able to get software updates, to be able to do whatever it is they need to do. You don't want to restrict the abilities of the container. unless like you're intentionally doing that or for security reasons. So what it'll do is it'll create a NAT network. So your Docker containers will have an IP that's something like 172.16.2.5 or something like that. And that IP address will get all the traffic going out will get kind of redirected through your host IP using NAT forwarding. And when you do port forwarding, like the -p command that I showed you before, you're explicitly telling Docker, hey, on the host machine, port forward port 80 to this container's IP, or to this container's IP port combo. And it'll do that for you. It's great. Another advantage of NAT is you can do the DNS stuff that I mentioned earlier, where if you put two machines on the same network, they can ping and talk to each other and automatically DNS resolve themselves. Very useful. Alternatively, you can use the host network, which is what I was saying originally. You have the same IP address for the container and the host. It's the same thing. Again, disadvantage, if the Docker container tries to spin up a port and that already exists on the host, it breaks down. But you don't have to worry about port forwarding. Whatever port opens on the container just opens on the machine. So let's say you're trying to use Docker for pen testing. There's a lot of people that run Docker or Kali images within Docker to do pen testing. If you're running Metasploit, maybe it wants to open a port to listen, like arbitrarily. Use the network, the host network, and you don't have to worry about that. It'll just automatically forward whatever port needs to get forwarded. There's also IP VLANs and MAC VLANs, which allow you to do networking based on IPs and VLANs. Basically connect your machine directly to the network that your host machine's on. So in this case, the RIT network on EDU roam, I could set an IP for a Docker container to connect directly to that network. There's also the none network, which is exactly what it sounds like. It's not a network. If you want to sandbox a container so that it can't hit the internet at all, put it on the none network, it won't hit anything. It's also worth noting that there's an overlay network. This is used for Docker Swarm, which is a way to connect multiple Docker servers together and orchestrate it from one machine. It's a little weird. I personally don't use Docker Swarm. It's something that you can look into. Docker's docs are great, so if you want to find out more, I would look there. It's not something that we're going to talk about today. More stuff that can make Docker complicated. Docker files and Docker Compose, they're really useful tools. They're Swiss Army knives. But as with anything that is very useful, it can be kind of complicated. So this is something that you're going to want to go to the docs for. Personally, whenever I'm writing Docker files and Docker Compose, I find that I look at cheat sheets very often. There's a lot of subcommands. It does a lot of things. It's useful to be able to consult something to double check. With that being said, they do give you a lot of power. Volumes can be complicated at times. There's a lot of different versions, like volumes, binds, temp file systems. Oh my. You can control if things are read-only or read-write. Control the permissions through this. That can be kind of weird. But overall, volumes just map files and folders to between your host and your container. So as a concept, they're pretty simple, but they do get nitty-gritty sometimes. Devices are really interesting within Docker. You can actually map USB devices, for example, into a Docker container. So if you have a serial connection and there's some sort of application that goes along with that serial connection, like let's say it's a medical device that your laptop doesn't support because it's so outdated, you might be able to still run that through Docker for that USB device into Docker and still be able to use that medical device that's super old and would otherwise need Windows XP or something, which is really cool. Really neat thing that you can do. I've also seen people do Wi-Fi sniffing with Kismet through Docker containers, which is really cool, but also really weird. But it's doable. You can do it. Capabilities. If anybody here has done Linux kernel stuff, you'll be aware of Linux capabilities. That's stuff like being able to root, make kernel modules, install kernel modules, stuff like that are all Linux capabilities. You can give containers capabilities, but if you listened, I said install kernel modules and stuff like that. That's dangerous. So if you give a container privileges that exceed what it needs, that can go downhill quickly for you. Let's say someone takes over your container and it would be otherwise secure because Docker's typically pretty hard to break out of, but you gave it the capability to install kernel modules. That guy's just going to make a nice little kernel module specifically for you and install that stuff and break out. Not ideal. Some weird stuff. Oh man, the Docker daemon. We'll talk about that in a second. We'll loop back. There's APT and apt-get. If you're using Debian or Debian-based images like Ubuntu with Docker files, you'll notice sometimes you get an error that will just like break Docker or the Docker build process. It'll say APT does not have a stable CLI interface. The solution to that is to use apt-get. APT and apt-get are otherwise interchangeable, except for with Docker files, you have to use apt-get or it'll get mad. Just one of those like weird things. Docker on Windows is a bit interesting because Windows will run Docker through what's it called? The Linux layer, WSL. That's what it's called, the Windows subsystem for Linux. It actually virtualizes the virtualization software that is Docker on top of a VM. So you have Windows, then you have a Linux VM, which is WSL, and then you have Docker and your Docker containers. So Windows is a bit funky. I haven't used it in a long time, so maybe it's gotten better. Yeah, if you're going to use Docker on Windows, I'd recommend just spinning up a VM or pulling something up on the stack. You're already dealing with a Linux VM, so you might as well do it with one that you can fully control, in my opinion. There's also Chasm. Chasm is super interesting. Chasm is a proprietary piece of technology, or at least a proprietary front end, that uses Docker on the back end to make ephemeral images like Firefox. I think they have one for like Tor. There's one for, what's it called? GIMP, stuff like that, different applications. And it'll give you a GUI front end for Docker, and it'll run any application, and it's really cool. I used to have that working, but it got funky, so I got rid of it. But it's really cool, and you should look into it. If you want to have like, just ephemeral VMs and stuff, like you can run full on Ubuntu through this. Very cool. I would look into it if you have a home lab and you want to like mess around with that kind of thing. It's very, very cool. And circling back to the Docker daemon, the way that Docker works is actually it runs a server on your computer, and that might be scary, but it doesn't open a port. The way that it does it is it creates a Unix socket, which is kind of like if you opened a port, but instead of it being a port on your network layer, it's a file on your system. So in order to make commands like Docker run, it'll actually make your command line client, the Docker command itself, will make a web request to this Docker socket that's in Docker or /var/run/docker.sock. It'll actually make a web request saying, hey, make an image with these settings, and it'll give like a JSON, a JSON piece of data with all this information in it, which is super interesting. And you can actually do a lot of stuff with this. Sockcat can forward this file to be an actual port, and then you can redirect Docker to talk to different Docker socks instead. So you can actually, it's interesting. But yeah, so if I go back, this REST API is the Unix socket on your machine, and then the REST API and all the stuff over there is actually your command line interface, like the Docker command. So it's like, it's cool. Anyways, yeah, we have a couple demos prepped for you guys. Go ahead and go into flags.ritsec. Is it .club for flags? I think it is. Go ahead and start doing the demos. There's a handful of them that I think will be pretty interesting, give you like a good, get your toes wet kind of thing. If you have any questions, I'm here. I'll be walking around and stuff. And yeah. Does anybody have any questions on the talk? It's kind of long. No? Okay.
I know, I'm pretty sure there's like a Docker, when you run like a Docker compose, there's a command where there's Docker dash compose and there's Docker space compose.
Yes.
I don't know if you
I didn't touch on this. Okay, so the question was about Docker space compose and Docker dash compose, which are two different commands. So my understanding is that Docker dash compose wasn't initially part of the Docker, I might be wrong, wasn't initially part of the Docker project. It was a plugin that someone made, and that plugin later got integrated into Docker. So it went from being Docker dash compose to Docker space compose, because that's the general formatting for the other commands. So Docker space run, Docker space build, Docker space compose. So that's a good question. Yeah, it's the same thing. They work exactly the same. Yeah.
Well, I know that there's like different ways to export like a container, like there's export safe and there's another one, right?
Commit. There's also commit, I think.
Yeah, what are the different
I've not. The question was about how to export images and the different ways to save images on the disk. I've actually not messed around with that very much. The main way that people, or the standard way that people will deal with images is either by committing them, which exports them to a tar. That's the way that I've seen it done. You can also push and pull images to an external registry. GitLab has a registry built into their software, and as you saw, I have a registry as well that I was running for demos. Typically, that's the way that you'd share images. I've not messed around with it very much, so I can't answer in more detail on that, sorry. Docker's documentation is really good, though. Yeah.
So you use Docker as like a container that holds things.
Yeah.
What else can hold things?
I have no idea.
Oh, RITSEC manual.
Wow.
This is Michael's first presentation. Well,
Thank you. I'm a bit disappointed that nobody asked me if I could use this offensively, because the answer is yes.
And it is being
It is being used offensively. Certain Home Depot and Lowe's capabilities. All right. Anthony has a question.
Things like Docker escape. I don't know if you're gonna know, but what's the general
The general escape mechanisms.
Yeah.
Oh yeah, we could talk about that. Okay. So the main I can't say that, but the main generic basic way of escaping containers, right, is through trooting. Actually, people do silly things sometimes. Okay, there's two or three big silly things that you can do. Earlier, I talked about the Linux capabilities where you can install kernel modules and stuff like that. That's a big one, although that's not the most common one because people usually don't mess around with capabilities of Docker. The big one is that people will either mount the Docker sock to their container, which is interesting because, again, the Docker sock is a file, remember? You can mount files with -v. So what people will do sometimes is they'll be like, I'm going to mount the Docker sock into my container. What that means is that in that container, you can tell the Docker sock to spin up images or spin up containers, build images, do X, Y, and Z. So within that container now has full privileges to do whatever the heck it wants to the Docker sock, which is dangerous because the Docker sock has a lot of root privilege stuff that it can do, like edit files, like etc shadow, for example. That's a bit dangerous. And you can also run containers as privileged, which means that you can see disks and devices connected to your computer, including your root your root disk, and then you can mount that disk. So once you mount that disk, you can root into that folder that you mounted it to, and now you're root in the the root directory of that host machine, and you can edit etc shadow and all of your config files and everything. You can read everything. So those are the three main ways that you'd escape, either through privileges, or Linux capabilities, privileged container, or through the Docker sock. If you have the Docker sock, you can do either of the other two. You can get creative. Yeah, that's how escape's roll. Any other questions? Cool. All right, thanks, guys.